Today we're going to work on dilating a line. So we're going to graph a couple lines and see if we can come up with a rule based on the pattern. So first, we're going to dilate the line y equals 2x minus 3 by a scale factor of 3 with the center of dilation at the origin. So here are our steps to decide. The first thing that we're going to do is graph the original line. Now to do this, we can either use our slope and our y-intercept or using our graphing calculator, and I'm going to use our slope and y-intercept. So I'm going to start at -3, and I'm going to use my slope to move up 2 and over 1, up my graph. I'm going to connect those points with a straight line, and that is my original line. I'm going to label it y equals 2x minus 3. Now I'm going to dilate the line, and I'm going to pick some points, by picking some points, and I'm going to use slope. So the first thing I'm going to do is I'm going to pick a point on my line. I'm going to start with this point right here, because when I dilate, I always go from the center of dilation to a point on my figure. So I'm going to go starting at my center of dilation, which is the origin. I'm going to count and see how I got to that point right there that I drew an arrow at. So I'm going to start at my center, and to get to that point, I would go up 1 and right 2. Now, because my scale factor is 3, I'm going to repeat this 2 more times because currently that's a scale factor of 1. So I'm going to do the same pattern, up 1, right 2, up 1, right 2. And this is a new point. I just dilated that one point with a scale factor 3 centered at the origin. I'm going to do the same thing, but with another point on my line. Any other point I can do it with, but I'm going to pick this one because it's close to my center. So to dilate that point, I'm going to go right 1, down 1. So I'm going to repeat that process, right 1, down 1, right 1, down 1. Here is my second point. And I'm going to connect those with a line. All right. And now I'm going to write the equation of my new line. And to do that, I need to identify the slope and either the y-intercept or a point, depending on which form you'd like to use. Slope and y-intercept will be helpful if you want to write it in y equals mx plus b or slope-intercept form, or if you want to write it in point-slope form. Then you only need 1 point on your line. You don't necessarily need to scale 2 points. So that could be helpful. In this case, I can see my slope by doing my rise over run. And I would find that the slope is 2 over 1 or 2. My y-intercept, in this case, I can see it on this grid. It's at -9. Or, like I said, if you would prefer, you could use a point that I just graphed. So, for example, if I wanted to name this point, I would say 3, -3. And then, depending on what type of equation you want to write, you can write it. So, if I'm going to use y equals mx plus b, slope-intercept, I'm going to say that that's y equals 2x minus 9. If I wanted to use point slope, I could say it's y plus 3 equals 2x minus 3. Both of those equations are correct. Just depends on which of these two here you use, which is why they're both indented. Can you make any observations? What's true about the equation of this line, my image, compared to the equation of my pre-image? So looking at them both, I can see that there is the same slope in both, but different y-intercepts. And how are the y-intercepts different? The y-intercept changed based on the scale factor. Now we're going to take another example. We're going to dilate that same line, but this time my center is at 3, 0. So let's draw in my original line. Again, my slope is 2, and my y-intercept is -3. So I'm going to plot these points and draw in my line. Graph my original line. Now I'm going to dilate the line using slope again. So again, I'm going to pick 2 points, but this time when I do it, I'm going to center it at 3, 0, which is this point. Actually, I'm going to draw it in a different color. I'm going to draw it in black. That is my center. All right, so I'm going to pick this point. Oh, excuse me, sorry, it moved. I'm going to pick this point again because it's close to my center. It's less counting for me. So to count to that point, I would go up 1, left 1. The scale factor is 3, so I'm going to do another slope triangle and a third slope triangle. So I have 3 slope triangles all together. Now I'm going to pick another point if I want. If I want to use slope-intercept form, I would pick another point. If I want to use point-slope, I actually don't have to pick a point. But I'm going to, because I think most of us like slope-intercept form. So I'm going to pick this point right here next. And I'm going to count to it. I'm going to go down 1, left 2. So again, down 1, left 2. Down 1, left 2. There is my new line. And now we need to write the equation. What is the slope? Again, if I draw in those intermediate points, you can kind of see where they fall. My new slope is still 2 over 1 or 2. What is my y-intercept? If I look at the y-axis, I see it crosses at +3. If I would like to use point slope, I can just name that point as 0, 3. Or you could use the other point that we scaled or any other point that is on this new line. And then we're going to write our equation. Y equals 2x plus 3. Oh, sorry. All right, again, we're going to look at our original line and our new line. And I want you to see if there's a relationship between the two equations. So again, we have the same slope, different y-intercepts. But in this case, our y-intercept did not change based on the scale factor. It changed in relation to our center, which doesn't give us a nice, easy way to find that new y-intercept other than graphing. Here's our last example. This time we have y equals 2x minus 3. It's dilated with a scale factor 3, centered at 2, 1. So the first thing I'm going to do again is graph my original line. Same line for a third time. We should be getting good at this line. Oops. Let's try again. All right, now I'm ready to dilate. But first I'm going to plot my center. It's at 2, 1. So here is my center. Oh, it's actually a point that's on my line already. Let's see how that's going to affect my dilation. So again, when I dilate, I'm going to pick a point near my center so that I can dilate that point around the center. So if I pick this point here because it's close to my center, I would go up 2/1. Oh, that sounds familiar. So if I'm going to do that and I'm going to use a scale factor of 3, I'm going to continue the pattern up 2/1, up 2/1. Okay, that's my new point. What if I pick this point below it now to try? I would go left 1, down 2, left 1, down 2, left 1, down 2. Here's another point. Oh my goodness, what has happened here? The equation of my line is still y equals 2x minus 3. The equation of the line did not change. The slope and the y-intercept and the line itself, look guys, are all exactly the same. Same line. Same equation. Now, all right, so now we're going to look at our rules and see if we can dilate using our rules. So if it is centered at the origin, what happened? The slope stayed the same. Stays this, yeah, that's how you spell same. Let's try again. Stays the same. And we can multiply our y-intercept by the scale factor. If I have a line dilation and it's centered at any point at all, here's our general rule, is that we can choose our point to dilate and use our original slope if we would like to graph the rest of the line. We only technically need to dilate one point. And lastly, the other scenario that we'll find ourselves in is if it is centered in a point that is already on our line. In this case, the equation stays the same. Now let's look at some examples and see how we can use our rules instead of necessarily a graph to help us. So first, line L has the equation y equals negative 3x plus 5. And we're going to graph the image after a dilation of a scale factor of 1/5 centered at the origin. So again, looking up here, we're going to have the same slope, but we're going to multiply our y-intercept by our scale factor. So if I want, I can label that our original slope is -3 and our y-intercept is 5, which means that for our new equation, our slope will be -3, but the y-intercept will be multiplying that -3 by, the y-intercept, which is 5, by the scale factor. So the new equation is y equals 3x plus 1. Let's do the same thing for the next one. Line L has the equation y equals 1/3 x minus 1. We're dilating it with a scale factor of 4, centered at the origin. So again, our original slope is 1/3. Our original y-intercept is -1. For our new line, our slope is the same. Our slope is always going to be the same, guys. But our y-intercept, instead of at -1, we're going to multiply it by the scale factor 4 to give us -4. So our equation is y equals 1/3 x minus 4. Now these next two, I did give you graphs, but you don't have to use the graph if you don't want to. The line y equals 2x plus 3 is transformed with a dilation scale factor of 2, centered at 3, 9. What is the equation of the line's image? So there are two scenarios here now that we have to think about or determine. One, it said, or up top, we had three different things. We had if it's centered at the origin, at a random point, or at a point on our line. So we're going to have to determine, is this a point on our line? So I'm going to ask myself, is 3, 9 a point on y equals 2x plus 3? And I can do that actually three different ways. One way would be to graph it and to see. So if I were to graph it, I would plot my y-intercept, plot my points, connect them, and see if it is a point on the line. Let's see, 3, 9. Right there, that is 3, 9, and that's a point on the line. Another way would be to go into y equals on your calculator, type in the equation, and see if 3, 9 exists in your table. And it definitely should, because it is on our line. So now that we know that it is a point on the line, yes it is, we can follow our rule that we just talked about on the last page. So since it is dilated by a point on the line, the equation is the same. So the equation is y equals 2x plus 3. Now you don't necessarily have to write that explanation, but I thought it would be nice to write it out in words. Now we're going to do the next one the same way. Y equals -x plus 2, transformed with a dilation scale factor 3, centered at -1, -1. So again, we're going to see, is this on the line? Is on line. Is this point on the line? Let's check it out. All right, so to do it with using a graph, I'm going to use a negative slope because it's a -x. Connect them with a line. And I'm going to see if -1, -1 is on my line. -1, -1, it is not. So because this is not a point on my line, I'm going to have to use my rule or use the method that we used earlier to scale this line. So let's write down, or let's dilate some of these points with a scale factor 3. So I'm going to pick this point to start. I'm going to go up 1, 2, 3, right 1. So I'm going to continue 1, 2, 3, right 1, 1, 2, 3, right 1. Here is a new point. And then I wonder if this one, does it give us enough? Not quite. Okay, why don't we go with this next point right below it next? We'll scale that point. Or we can, now that we have 1 point, based on our rule, the rule says that the slope stays the same. Anytime in a dilation, guys, the slope stays the same. So because of that, I can just graph the rest of my line based on that rule that I'm going to have my slope is still going to be -1. So -1 over 1 all the way down my graph. And here is my new line, which is not super straight. There we go. And I just need my new y-intercept to state the new equation of my line. And I can kind of see that the y-intercept looks like it hits at +10. Which means that the equation of my new line is y equals -1x plus 10, or just y equals -x plus 10. You don't necessarily need the -1.